Good evening, everyone. Can someone confirm if I'm audible? Oh, thanks.
Yes, sir.
Okay, so let's start live session for the week 6 for the course Digital Circuit, which is taught by Professor Shantanu Chattopadhyay from IIT Kharagpur, and I'm Anant Singhal, a PhD student from IIT Jodhpur. And today I'll be assisting in solving some of the similar assignment problems that have been assigned to you in your week 6 assignments. So as we have already covered like half of the course that was more or less related to the combinational circuits. Uh, so now we'll be moving towards some of the, I can say some of the more important or the most important topics of this particular course that is related to the sequential circuits. So if I go to the course outline, so in the last week, if you remember, we already covered some of the arithmetic circuits and also the multiplexer decoders, etc. So PLA is the only topic that was not there in the last week. And if I'm not wrong, in your assignments also now in the week 6 assignments, sir, there are problems which are related to this sequential circuits uh, that are basically some memory element circuits. I'll let you know what is the basic difference between combinational and sequential circuits. So yeah, so from this week onwards only we'll be starting this topic, which is a very important topic. So I'll highly recommend to please at least watch the videos of the YouTube recording that I upload later if you're not able to attend the sessions regularly. So yeah, without much further ado, let's start the session. So as we have seen that we'll be starting with a very important topic that is called as sequential circuits. So can anyone tell a basic difference between a combinational and a sequential circuit? Any guess? I hope that the theory lectures are already there and you have already watched some of the lectures. So yeah, anyone wants to uh, give any comment on what is the basic difference between a combinational and a sequential circuit? Okay. So what we have been reading or what we have been studying in this particular course till now is all the combination circuits. So the basic thing here is they do not store anything, whereas sequential circuits basically is like a memory. Like in your computers, you have a random access memory, random read-only memory, like that. So that consists of some clocks that is basically helping in realizing or giving the connection between the related output and input. So let me give you a very basic example. So for example, let's say a combination circuit we were studying about, let's say a multiplexer. Let's say we have our output something called as AB plus CD. So whenever we are giving like some input, which is A, B, C, D, and a plus. So this is the output Y. So this output Y is only valid when we have a certain ABCD. Let's say we do not apply anything here, so there will be no output in this circuit, right? Because it is not storing anything. Now, let's take a very basic example that will help you understand more. So let's say I have a NOT gate, and let's say here I have applied a 0. So what will be the output here? Anyone please quickly?
1
Yeah. So let's say now what I do is I'll take one more NOT gate. What will be the output here?
and 0.
Yeah, exactly. So what you have given is 0 input. So till you have given the 0 input, you are getting a 0 output. But what if what I will do now is I'll connect this output to the input of this particular thing. So let's say at maybe time t, you have given here a input that is 0, right? So this will give it 1, right? And then this will give it 0. And since this is connected to this, which is the input, so what it will do is it will store this bit, right? Are you able to understand? So let's say this is what you have given 0, the second is 1, then it's again 0, and since this is connected, this particular thing is connected to the input, it will keep on going like that. So you are able to store this 0 bit in this particular a very simple circuit that we call as a ring oscillator or a 2 input NOT gate, 2 NOT gate circuit. So you are able to store this particular bit, whereas if I have given, let's say, a 0 here, or let's say 0 1 0 1, something like that here, and you know that the output will be 0, but you are not able to store it because once you remove these inputs there will be no output. But here, in even if you just give the input one time, that is 0, it will store it always till whatever time. Let's say now at time t2 you want to watch what is the input or what is the output, you will be able to check that because it has stored that bit. So this is the basic difference between a sequential and a combination circuit. It is a memory, whereas the combination circuit, they do not store anything. Is this thing clear to everyone?
Again, regarding the sequential circuit, when how to store the memory.
Okay, so as I said, let's say I have given an input which is, as I said, 0 here. Let's say I've given it in morning 8 a.m., for example. So what this circuit will do, according to the circuit that we have made, this will be 1 and this will be 0 all the time, right? Now since we have connected the output of the circuit to the input of the circuit, so this 0 will always remain here. Now let's say you come back at night, which is time t2, 8 p.m. What, even without giving any input, you will be able to see that the input is still 0 and the output is still 0, right? Does it make
Yeah,
sense? But here if you see, let's say you have given this input in the morning for the combination circuit and we get the output y in the morning. But now when you come back, you have to again apply those inputs, right? Then only you will get the output. But here it is not the case because it has stored this particular bit. So this is a very basic sequential circuit example. So this is storing, let's say, a 0 or a 1. Let's say if I give it 1 in the morning, it will store 1 in the evening also. Is it clear now?
yeah,
Oh, yeah. So we have different types of sequential circuits that are being covered in this course. So I'll name some of them. So there are, so the sequential circuit is what basically we call as flip-flops, and we'll be using flip-flops to store certain bits that we want. So there are four major kind of flip-flop that are being covered in this course. The first one is SR flip-flop. The second one is JK flip-flop. The third is the D flip-flop, and the fourth is the toggle flip-flop. Oh, sorry, the T flip-flop. So SR here represents set reset. T here represent delay. T here represent toggle. So there is no as particular full form for JK. It is named after a scientist called as Jack and Kilby, but yeah, we do not have a proper name for this. So these are the flip-flops that we'll be covering in this course, and we'll be seeing one by one what are their functions and how do they work. So let's start quickly with the SR flip-flop. Can someone confirm if this is already being taught in the theory lectures by Professor Shantanu? Anyone? Okay. Fine. So we have the first one, which is SR flip-flop. So since we can again have four combinations. So here, as you can see, the input and output are dependent upon the previous inputs and outputs. That means this output is dependent upon the input that you have applied. So input and output are dependent on each other. Hence, what we call as, sorry, we call as the final output as Qn plus 1. That is the state which is the next state. So Qn plus 1 is nothing but the next state and Qn is the present state. So the basic function of a SR flip-flop is when both the bits are zeros, it retains the previous state or the present state. When set is 0 and reset is 1, so it resets the flip-flop. That is basically, yeah, it resets the flip-flop. That is the next state should be 0 then. When set is 1 and reset is 0, so it set the flip-flop, so it will be 1. And when both the inputs are 1, so it is invalid. So there is no output when set and reset are 0. Oh, sorry, 1. So this is a basic truth table of a SR flip-flop. So there are three kind of table that is associated to every of the flip-flop. Let me name them. So one is the truth table that you have already read in a combinational circuits also. So now there are two more tables that you have to be aware of. One is called as a characteristic table, and the last one is called as the excitation table. So in the truth table, in general, you see that we have certain input and we have certain output according to the inputs that we have. That is basically this, that what is the next state based upon the input which are S and R. The characteristic table has input. It's again giving some problem. Yeah, so the characteristic table has some input plus present state, and it gives the output as the next state. Then the excitation table has Q and the states as input, and SR that are the inputs as output. So this is basically the left hand side of the table, and this is basically the right hand side of the table. So truth table you already might be aware of because we have made a lot of truth tables in the combinational circuit, but these two are new tables that is that help you realize in how exactly SR flip flop works. So let me make a characteristic table first for SR flip flop. Let me make it here. So as I said, in the characteristic table, what do we have is we have SR as well as the present state as the input, and the next state will be the output. So we can have 8 combinations. So I want your help in solving. So please be attentive or please be interactive. So as I said in the initial table, when both S and R are 0, it retains the present state. So in this, sorry. So in these two cases, when S and R are 0, what will be the output? Qn plus 1? Anyone?
Even
Yeah, it will be Qn, right? So Qn is this. So it will be 0 and 1. When S is 0 and R is 1, what will be the output? From here you can see.
0.
Yeah, so Qn plus 1 is 0. When they are 1 and 0, so it is basically 1. And then when both of them are 1, so it is invalid. So this is what our characteristic table looks like. Similarly, we can also make our excitation table.
Again the first one, when both are 0,
Hmm.
how the Q1 plus 1 becomes 0 and 1.
Yeah, so as we can see, when both S and R are 0, so Qn plus 1 is basically equals to Qn, right? So Qn is this present state. So whatever the Qn is, I have just written it here. Sorry. Is it clear?
Okay, okay, okay.
Yeah. So similarly, we can make the excitation table in which what do we have? We have Qn and Qn plus 1 as the inputs and SNR as the outputs. So we can have again 4 combinations. So now we can clearly see when both Qn and Qn plus 1 are 0, which is basically, let me do use some different color. Maybe this one, yeah. So here you can see, here they are both 0, and there is one more case where they're both. So you can see S is always 0 in both the cases, and R can be either 0 or 1. So can I write 0? Oh, sorry. Can I write 0 and X here? Is it clear to everyone? I have written this. Okay, I'm assuming it is clear since you're not responding. So there is Qn and Qn plus 1, which is 0, 1. So there is only one case like that in which S and R are 1, 0. So I'll write that 1, 0. Similarly, 1, 0 can be here. Yeah, there is only one case where they are 0, 1. And at last, maybe I can use black. So it is 1, 1. So Qn plus 1 is 1, 1 here as well as here. So here S can be 0 or 1, so I can write X, but R should always be 0. So this is the excitation table now.
And again, what is the value of R? Why it is cross multiple
Yeah, so R is
when both are
cross
zero?
because, yeah. So let me give you the example by highlighting. So when Qn and Qn plus 1 are 0, so there can be two cases which are basically this one and this one. And here you can see the corresponding S and R values are this. So in both these cases, S is 0, right? So that is why we have written this 0 here. And but you see, R can be anything. It can be either 0 or it can be either 1. So we don't care about whatever the R is. R can be anything. So that is why I've written X. X means don't care.
Okay, okay.
Yeah. Yeah. So these are the three tables that we should be learning about all the flip flops. So this is about SR flip flop. Is the SR flip flop clear to everyone?
Sir, what is the use of excitation table, sir?
So excitation table, basically, as you can see, it gives you the certain, let's say you have a maybe a sequential circuits in which you know that this is the output that you are getting, and you want to know what is the input or what are the inputs that are being stored in the circuit. So you can see from here that this is the output, then these could be the inputs, or these table are also used to convert one flip flop from another. So I'll do some problems regarding that, that will make it more clear later. So yeah, we can also have the expression of Qn plus 1 in terms of SRQ. So in generally we use characteristic table. So we can make a K map. So we have, so this will be S bar S. So this will be R bar Q bar, R bar Q, R Q, and R Q bar. So we can write it as 0, 1, 0, 0, 0, 1, 0, 1, X, X. Yeah, so this is basically the excitation, oh sorry, the K map for the same. So one quad we can make is this. We can use this don't care, and there is only one way we can make a pair, which is this. So I can write, so this is basically a table of output is Qn plus 1, and the output is S plus R bar Q, and this is basically N. So this is the characteristic equation of a SR flip flop. Is it fine, everyone? SR flip flop. Okay, so now as you can see in SR flip flop, we had one condition in which when both the inputs are 1, we are getting an invalid output, right? So to counter this invalid output, we created one more flip flop which is called as a JK flip flop. So the basic difference between JK and SR is only that condition in which when we have 1 1 as an invalid output. So let me try to make the truth table, that will make it more clear. Okay, maybe I can make it here only. So JK we have, and then Qn plus 1. So again we can have 0 0 0 1 1 0 1 1. So as was the case in SR, the Qn plus 1 is Qn only, 0 1 is again 0 only, so it is like a SR. So when reset is 1, it is getting reset, and in 1 1 case what it happens is it makes it the complement of the output. So this is the core difference between a SR and a JK flip-flop, that for the 1-1 condition also we have a complementary output which is QN bar. So again, using this information, we can again make the excitation table as well as the characteristic table. So this is the truth table. So if I want to make the, not the excitation, but the characteristic quickly. So what I'll be having Qn as an additional input and Qn plus 1 will be the final output. So please again help me out and let me know the answers quickly. What will be the output of the corresponding cases? Sorry. Yeah. So let's start with when both J and K are 0, 0. What will be the output of Qn plus 1? Anyone?
0.
Yeah, so it will be 0 and here it will be 1 because it is equals to Qn in this case. Sorry for that. Yeah. So for 0, 1, the output is always 0. For 1, 0, the output is always 1. But now here we need to be careful that for 1, 1, what is there? So Qn plus 1 is nothing but Qn complement. So it will be 1 here and 0 here. Is it clear to everyone? Please let me know quickly if it is clear so that we can also quickly make the excitation table. Okay, fine. So excitation in that we have Qn and Qn plus 1 as inputs and J and K as output. So it can be 4 conditions. Now we need to check when Qn and sorry. We need to check when Qn and Qn plus 1 are 0, 0 here. So it is one case here and one case here. So what will be just J and K?
0 and X.
Yes. Good. So similarly, we can go for all the cases quickly. When Qn plus 1 and Qn are 0, 1, so there is one case here and one case here. So quickly let me know what will be the J and K. It will be
1.
1 1, sir.
yeah. So similarly now we have 1 0 here and 1 0 here. So we can clearly see it will be x1 and at last it will be x0. You can check it. So this is the excitation table for a JK flip flop. Now again we can make a truth table. Oh sorry, we can make a K map out of the characteristic table and let's check the expression Qn plus 1 in terms of J, K and Qn. So yeah, let's make that quickly. So this is J bar J, K bar Q bar, K bar Q, K Q, K Q bar. So it's 0, 1, 0, 0, 0. So what can be the possible pairs in quads that we can make? Qn plus 1 is equals to. So one is clear that we can make this. And second, the only combination that we can make is this with this without using any redundant term. So the first is J Q bar plus K bar Q. So I can write it N because it is the previous state. So this is the characteristic equation of a JK flip flop. Any doubts here?
Sir, can you please explain how we did the truth table, sir?
Oh, truth table. Okay. So for
K map. How did we did K map from truth table, sir?
oh, K map is easy. Like that is what we do in general, right? So this is when j, k, and qn are 0. So this is the case of 0, 0, 0, which is this block. So I just write 0 from here to here. When k map in k map when it is 1, so let me write in decimal 2, 3, 4, 5, 6, 7. So basically at input 1, 4, 5, and 6 I had ones and rest are zeros. So that is basically, sorry, where did it go? Here. So if you remember, we write like this: 0, 1, 2, 3, 4, 5, 6, 7. So at 1, 1, 4, 5, 6, I have written 1, which is this, and this.
Sir, from characteristic table, we do K-map, sir, for
Yes,
this.
because we want to have expression of next state in terms of all the possible inputs. For the SR flip flop also we did like that. Remember, we want to have a characteristic equation, so that is why we are calling it even the characteristic equation, because it is giving you the relation of the next state in terms of the present state and the inputs. Is it clear?
Yes, sir.
Okay. Yes. Who has raised the hand? Is there any doubt?
Yeah, for SR, it is actually one is invalid state, right? How can you use it as don't care and club them?
Oh, yeah. So one is, yeah, that is true. So invalid means whatever, we don't care about what is whatever we are getting when we are applying any input. So we have to treat it like a don't care, because we don't we are not getting any input or output for that particular state. So that is why we have treated it like a don't care. Yeah, don't get confused between invalid and don't care. So they are basically the same thing. It's just that you know that you cannot apply 1 1 as an input to SR flip flop, because then you will be not getting a valid output. So basically we don't care about when we are applying 1 1 as an input. Just to fix that, we have to make this JK flip flop so that we can have some finite toggling that is happening for this particular state. Okay. So then we have two more flip flops that are D and T, that are very easy, because D flip flop is a single input flip flop. Similarly, the T flip flop is a single input flip flop. So in D, let me write it quickly because I'll not take much time. So let's make the characteristic table directly. So in D flip flop, what happens is whatever the D is, that will be the output. So what I'm trying to say is it will be 0 0 1 1. That means Qn plus 1 is equals to D. And in T flip flop, oh, sorry, I'm doing this quickly because it is also similar to what we have already done above. So in T flip flop, what happens is the input toggle. So whenever the T is 0, the Qn remains Qn. Whenever the T is 1, it remains, it changes to Qn bar. So let me write that too so that you can remember. So here it is Qn, here it is Qn complement. And if you try to again make the K map, it will give you T XOR Qn. So these are all the characteristic equation of all the flip flops that we'll be
Sir,
needing. Yes.
sir, D flip-flop is simply like a ring generator, no, sir?
D flip flop is what?
Like you have said in the starting of the class, no, sir?
Yeah,
Ring,
yeah. Yeah, like
ring.
a buffer circuit. Whatever the input you will be giving, you will be getting the same output. Yes, that is true. Like a ring oscillator, I think you are referring. So this is actually like a buffer circuit. You can make it like this. So that is why we call it as a delay flip flop. It basically delays the input and output. Make sense?
Yes, sir.
Yeah. Okay. So let's maybe, yeah, do some basic questions on these things, on whatever we have understood till now. Yeah. So in this question, it says in a JK flip flop, toggle means anyone? Okay, yeah. So it is a very basic question. So C will be the correct answer. As I've said, JK flip flop is only made when J and both are 1. So basically, the next state toggles, which is basically the complement of the previous state. So it basically changes the output to the opposite state. Let's go ahead. So the output of SR flip flop when S is 1 and R is 0 is, yeah. So if you remember, I can make the truth table quickly. So it is something like this.
One. A is correct answer.
Yeah. So the question is when S is 1 and R is 0. So yeah, so 1 will be the correct answer. That is option A. Here option C was the correct answer. Okay, let me try to get this problem. Yeah, let's try to do this now. Yeah. Okay. So now this is the one of the questions that we have. So it has a clock, it has an input, it has output. So first of all, by seeing the problem, let's ignore the positive edge triggered for now. You can clearly see that in the problem we have one input and one output. So what can be the possible answers? Can you eliminate some of the options? Anyone wants to comment? Okay, so as you can see, there is only single input and single output. So if I can go back, so in, let's say in SR flip flop there were two inputs and one output. In JK there were two inputs and one output. But in D and T flip flop there was a single input and a single output. So can we clearly say that it cannot be, where did it go? It cannot be a JK or SR flip flop. Does it make sense?
Yeah.
Yeah. Now the question says the waveform indicates the operation of. So now in clearly in all the options you see it is a positive edge triggered. So let me explain what does it mean. So at every flip flop, for example, let's say it is a SR flip flop, there is a clock that is present. So this is a symbol of a clock and there is this Qn and Qn plus 1. This is how we make it like a box. So this is like a SR flip flop. So it only works at either positive or negative edge of the clock. So this is a clock basically. So if it works, so this is the positive edge of the clock when it is going from low to high. I hope you are able to understand this. So if it is changing at low to high, then it is a positive edge triggered flip flop. And the same goes when it is changing from high to low. When the output is changing at these edges, then it is called as a negative edge triggered flip flop. Is this clear to everyone?
Yes.
Yeah, if it is clear, then I think the question is pretty easy now. So now we have to only need to check the positive edges because all the options are positive edge triggered. So at this particular edge, the input is 0, the output is 0. Yes, is there any doubt? Who have raised the hand?
Yeah, actually input and output, input is Qn and output is Qn plus 1, or input is
No, no.
S.
Yeah, input is always either S, R, or J, K, or D, or T.
Okay.
Qn is the state. It is a present state. You cannot say that this is the input. And based upon all these combinations, there is a next state that comes as an output. So this
Okay.
is the output. Yeah. So now if you see the negative positive edge, so here the input is 1 and the output also changed to 1. If you see here, the input is 0 and the output also changed to 0. Now here the input is 1, the output also changed to 1. Now here the input is 0 and the output also changed to 0. At the last it is 0 and it still remains 0. So can you see that whatever the input is it equals to the output?
Positive C, answer C.
Yeah. So when, as I have said, then Qn plus 1 is equals to D. This is basically a delay flip flop. Whatever the input is coming, we are getting the same output. So the correct answer would be option C, which is a positive edge triggered D flip flop. Okay. Shall we move ahead? Okay. Now this is the next problem. It says a flip flop converted from a JK flip flop is. So basically now this is a JK flip flop and you have to like do some exercise to check whether it is by making these combinations initially, whether it is changing to a SR or a, what is the options? Yeah, SR or a D flip flop. So let's try that out. I mean, let me try to solve this and you can also try it parallelly. Do you want to solve it by yourself? Shall I give you 2-3 minutes? Please let me know if you want to solve it by yourself and then okay, so let me try to do this problem by myself. Yeah. So for these types of problems, you should always remember at least the truth table of the JK flip flop. You should always have this in your mind that we know it is Q and this is 0, 1, this is Q and complement. So why I'm making it, because we can have different combinations of X and Y and we can calculate X and Y in terms of Qn plus 1 so that we can see what exactly is a XY flip flop. So let's try to do that. So let's say this is X, Y, J, K, and let's say this is Qn plus 1. So X and Y can be these cases, right? Now you can clearly see, so this is J and this is K. So if I, let's say if I take 0, 0 as a input, which is the first case, what will be J and K? Anyone? So this is basically a AND gate. This is an AND gate.
0 0, sir.
Yes. When X and Y are 0, 1, so J will be 0 because it is a AND gate, and 0 and 1 will give me a 1 here, if I'm not wrong. So K will be 1. So this will be 1, 0 then. And when both are 1, so this is 1, this is 1. When both are 1, it is 0, so it is 0, 0. Is it clear to everyone? X, Y, and JK? How I've converted that?
Yes, yes.
Okay. So now when jk is 0 0, you can clearly see it is equals to qn, right? So let me write that. Oh, sorry. So let me use some different color. As I've written above, it is qn, 0 1 is 0, when it is 1 0 it is 1, and when it is 0 0 it is again qn, right? Is there any doubt in this?
Yes. Yes.
Yeah. So now you can clearly see when it is 0 0 it is storing the state, when it is 0 1 it is 0, it is when it is 1 0 it is 1, but when it is 1 1 it is again storing the state. This is the only difference that we are getting. So can I say that this is nothing but a SR flip flop? Because in the 1 1 case that was the only invalid case in flip flop and we don't care about that. So first of all, we can eliminate these two options directly because there are two inputs that are X and Y. So it cannot be a D flip flop. So X and Y should be like in this order S and R, so that when set is 0, reset is 1, it should be 0. So S should be equals to X and Y should be equals to R to make this a SR flip flop, which is basically this particular circuit. So the correct answer would be option B. Is it clear to everyone?
Yes.
Okay. So let's move to the next problem now. It says which of the following is correct for a D type flip flop? So yeah, let me know the answers in the chat box quickly and then we'll proceed to the next problem.
Answer is A.
Yes, so the answer will be A. So it says the Q input is either set or reset as soon as the D input goes high to low. So yeah, basically, as we have already established that whatever is the D is the Qn plus 1. So D is this, Qn plus 1 is this. So whenever there is a clock coming up, the D changes, the Qn plus 1 is equals to D. So this is correct. Let's also check the other statements. The output complement follows the input. So it is not complement, it is actually the actual output. So this complement is wrong. Only one of the inputs. So actually the D flip flop is only having one input. So this cannot be correct because it only has one input. Then the output toggle. So again, it does not toggle because it remains equals to the next state or the previous state. Sorry. So option A is the correct answer. Is it clear? Okay, so maybe I can
Yeah.
explain you one of the key topic, that is the flip flop conversion, which is very important. So let's take a question in terms of that. So the question is implement D and T flip flops using JK flip flop. Are you able to understand the question? You have to implement or you have to make a D flip flop, but you have a JK flip flop in your hand. How will you do it? This is a basic question. And then the second part is you have to do the same with the T. So let's start with one by one. So the first part of the question says D flip flop using JK. So there are three major steps that are involved in this. Let me explain that, or let me try to do that. You have to like learn them. So the step one is you have to make the characteristic table of the required flip-flop. So in this case, you require a D flip-flop. Step 2 is make the excitation table of the available flip-flop. So in this case, the available flip-flop that you have is JK. Step 3 is write available flip-flop in terms of required flip-flop, so that you can get a relation between D in terms of J and K basically. So available means J and K in terms of D, and yeah, Qn should be there. So are the steps clear? I'll do it one by one. I mean, I'll do the steps also. That will make it more clear. So let's start with step 1, which is make the characteristic table of the required flip-flop. So I think we are quite aware now how to make that. So let me make that. So it's basically D, Qn and Qn plus 1. So yeah, it's basically 0, 0, 1, 1. Qn plus 1 is nothing but D. Then the second step was to make, so this is 1. Maybe I can use the different color. So the second step is to make the excitation table of the available flip-flop, that is JK. So let me make that. It would be good if you can remember these tables because that saves a lot of time. So yeah, it's 0x, we have just done it. So it's, I think, x1 and x0. So these are the two steps that we have done. Now the third step involves write available flip-flop which is D in terms of required write available flip-flop which is JK in terms of the required. So what we can do is we can write a JK here. So this is the step 3. So when Qn and Qn plus 1 are 0, so we'll use this table to fill this. So it's basically 0x, 1, 0 is x1, 0, 1 is 1x, and 1, 1 is x0. Is it clear till here? Is there any doubt?
Hello, sir.
Yes.
Could you please explain it again?
Which step?
Sir, this step that 3 1 3.
Okay, so the step 3 is basically I've used this characteristic table. So when Qn plus 1 is 0, 0, we know that JK is 0x. So when Qn and Qn plus 1 is 0, 0, I've written 0x. Similarly, when it is 1, 0, which is this case, it is x1. So written is x1. Like that, yeah, I followed it. When it is 0, 1, it is 1x. When it is 0, 1, it is 1x. And similarly for the last.
Okay, sir. Thank you.
So once you have that, now you can make a quick K-map to have the relation of JK in terms of D. That is the last step to do that. Yeah, let's make that. So we'll use D and Q as input. So D bar D, Q n bar Q. So this is for J. So it's 0, 0x, 1x. So there is only one pair. So J is basically equals to D. Similarly, we can make for K. K is x1, x0. So this is the only pair and this is D bar. So K is equals to D bar. Is this clear to everyone? So this is how you make a D flip-flop using a JK flip-flop. So basically what
Yes, sir.
you had a
The
JK.
third step again the third step of convert it.
Yeah. So you had this with you with a clock, let's say. So now what you have got is you have to have a single input that is D. So J is equals to D and K is equals to D bar. So this is how you are made. So basically now this box is a D flip-flop, and you have made it connections like that. It has been made using a JK. Yes. What is the doubt?
D bar for K, the table which you have done is for with D bar and Qn or Qn plus 1.
No, it's Qn. You cannot make a table of Qn. Okay, let me clear that. So basically, you want to find a relation between J, D, and Qn. So for example, this. So the first table corresponds to the things that I marked, because you will be having a relation of J in terms of D and Qn. Then only you can make the circuit. You don't know what is the Qn plus 1. In the block, you only know what is either Qn or what is either the inputs. Similarly, for K also, I have done the same. Is it clear? Please let me know if you have any doubts.
No, the same third step after first to start the second step. The third step how it converted as 0x, but the next line is x and 1.
Yeah. So this is not clear, you are saying?
Yes, yes.
Oh, this is I have just taken from here. As I told you, the yellow highlighted region when Qn and Qn plus 1 are 0, 0. So J and K are Q 0 and X. So this is what I have just written. By checking the Qn and Qn plus 1, I have just written the J and K from the using the excitation table. That was step 2. That was the only reason that we made the excitation table.
Okay, okay.
Yeah. So I made a JK flip flop. Sorry, I made a D flip flop using a JK flip flop. So now can you try using a making a T flip flop using JK by yourself? Okay, let me do it very quickly because the steps will be same. So the step 1 was to make the characteristic table of the required flip flop. So for the T flip flop, it was XOR, so it is 0 1 1 0. So this is the first step. The second step was to make the characteristic table of the excitation table of the available flip flop, that is JK. So 0 x 1 x x 1 x 0. Now the third step is to write JK in terms of T. So when it is 0 0, we know it's 0x, 1 1 it's x 0, 0 1 is 1x, and 1 0 is x1. So now again I can make sorry, we need to write what is happening. T bar, qn bar, qn. So this is basically 0 x 1 x. So j is basically equals to t. Similarly, k is x 0 x 1, which is again equals to t. Is this clear to everyone?
Yes, sir.
Yeah. So now similarly we can make a circuit like this. So we had a JK flip flop in our hand, and if we just make a single connection and join them, because J and K are both equals to T. Sorry. So now basically this dotted box is a T flip flop that we have made using a JK flip flop. I hope it is clear because this is very important to understand.
Yeah, yeah.
Okay. So if it is clear, let's do a question based upon that. So question is, you guys can try for 5 minutes and then I'll solve. So the question is the truth table of a, let's say I'm calling it a X5 flip flop, is like this. So it can be, so Qn is Qn bar 1 0, and let's say this is Qn bar again. So you have been given, let's say, a X5 flip flop. The question is design a flip flop which is XY using again a JK flip flop. Is the question clear to everyone? Please let me know if the question is clear. So there is one required flip flop, there is one available. So which one is available?
XY.
No, JK flip flop is available to you and you have to make a XY flip flop using that. As I said, design
JK is
a,
available.
yeah, you have to use or you have to make a X5 flip flop using JK flip flop. So now based upon the steps, that are these 3 steps, which is step 1 is make the characteristic table of the required flip flop. So in that case it is XY. Step 2 is excitation table of the available, in that case it is JK, and step 3 write in terms of that. So do you want to try it? I think it would be a good exercise. Are you able to understand the question now? Okay.
Yeah, yeah.
Okay, just try it out. Again, I'll show the question. Take 5 minutes and let me know the answers that you are getting. So basically answers would be J is some function of X and Y. Let me write the options also, maybe that will help you guys. So the options are, the first option is J is maybe X, Y bar. K is coming out to be X bar Y. The second option is J is X plus Y bar. K is, the third option is X bar plus Y. K X plus Y bar. And the fourth option is J is X bar Y is X Y bar. Yeah. So take 5 minutes and let me know the answers in the chat box. Okay, let me write maybe ABCD. Did anyone try? Is there any particular step that you are being stuck? You can ask. Okay, so as we know, the first step is to make the characteristic table of the required flip-flop. So everyone was able to make the characteristic table. Please respond to this. Either say yes or no. Yeah. So if you are able to
Yes,
go to
sir.
the excitation table, can someone quickly tell me what is the Qn plus one that you all got? So what is the Qn plus one? Can anyone open their mic and let me know in the order? What do you mean by 0011? There are 8 Qn plus 1.
10101010.
10
10 again q and complement.
1010. Are you sure?
Yeah.
So when x and y are 0 1, I can see it's 1.
Oh,
So it should be 1011, I think. Then
no, I just made the complement of q and so I'm wrong.
okay, so here it will be 00 because 10 is like that, and 11 is a complement, so it will be 10 again. Is this clear to everyone? Just to make it easy, I can make it like that. So you already know when x and y are 00, the qn plus 1 is qn complement. When they are 01, it is 1. When it is 10, it is 0. And when it is 11, it is again qn complement. Is it clear the first step? I mean, I hope everyone was able to do it. Yes, so this is the characteristic table. So in this q and x like I input. So now using the excitation table of j and k, we have to fill this. So step 2 is to make the excitation table of j and k. So I'm assuming till now you are able to remember it. So for 01, which are here and here, the j and k is 1x. Similarly for maybe 10, which is here and here, j and k is x1. For 01, which is here and nowhere else. Oh, so there is one more 01 actually. My bad. So it's actually red, which is this. It is 1x again. 1100, then 10. Okay, so there is one more 10 also. For this, it is x1, and then there is this 11. Oops, sorry. For 11, what is j and k? It is x0, I think. And the only list is left is 00. Let me also write that using a different color. 00, it's 0x. Are you all able to do this thing till here? Because if you have done it till here, then it's very easy to do JK in terms of XY. That is just a K-map problem. Please let me know if it is clear till here. Okay, so let me make the K-map now. So what I want is, I want, let's say, XY in terms of J and K. So let's first do maybe J. For J, I'll use X bar X. This will be Y bar Q N bar. Y bar Q, Y Q, Y Q bar. So let's fill the K-map. It's 1 X 1 X 0 X 1 X. Yeah. So one is this quad. The second one could be this quad. So I can write J is equals to X bar plus this is X square, Q bar is equal Y. Please let me know if you are all able to understand this. Yeah, great. So similarly, you can make for K, since only one option has X bar plus Y. So I think C is the correct answer. So K should come out to be X plus Y bar, if I'm not wrong. So now, since you already have the relation, what you had in your hand was a JK flip flop. So this is JK. You had a QN, you had a QN bar. So now J is X bar. Let's say this is X bar plus Y. And let's say this is Y. If I do a knot of this, plus Y is J. And X, now if I do a knot of Y, a plus of this is K. Now this box that you see is basically a XY flip flop using a JK flip flop. Are you all able to understand this? Great. If not, please try to rewatch the video, because these all are quite important things that you should be knowing. Okay, so let's try some more problems. Okay, so this is a PLA problem, which is program logic array. So this is actually pretty easy. Whatever the cross that you see is the actual connections. Let me make them, just making the dots. So for example, so this is X and this is Y. So X is connected to this, this, and this, which is basically, so the first is this, which is, oh sorry, this is A bar, B bar, C. So if I write X is A bar, B bar, C, plus the second is this, which is A bar, B, C bar, A bar, B, C bar, plus the third is this, which is A, B bar, C bar, and the fourth is the last one, which is A, B, C. Is there any option like that? So this is actually C. A bar B bar C plus A bar B C bar plus A B bar C bar. Yeah. So option B is the correct answer. Is this clear to everyone? This is a straightforward question, so I've not elaborated much. Wherever the connection is, you just need to write the expression for that. Please let me know if it is clear quickly. Okay. So let's do maybe one quick counter question.
Sir,
Yes.
sir, this single line and the crosses means the all those inputs are taken from there, sir.
Yes, yes. Every cross means all the inputs are taken. Maybe I can, wherever the cross is, it is actually connected there. For example, this is A bar, this is B bar, and this is C. So A bar, B bar, C is coming here and going here, X. So the first part is A bar, B bar, C, which I have written here. Similarly, you can write for all.
Sir, that single line represents three connections at A
Yes,
bar,
yes.
B bar, C bar, sir.
Yeah, yeah. It is just a way of representing it. It is actually, I mean, more inputs. But yeah, this single line represents A bar, B bar, C. That is true.
Okay, sir. Thank you, sir.
Hmm. So yeah, let's do a quick counter question, which is one more important topic. Let me make a circuit. Let's say this is J2, K2, Q2, Q2 bar, J1, K1, Q1, Q1 bar. Okay, so it's not pretty easy.
Hello.
Yes,
Hello.
yes, who is this?
Sir.
Yes, J naught, K naught, Q naught, Q naught bar. It is connected here, and it is connected here. So yeah, this is a question in which is called as a counter question. So it says the initial Q2, Q1, Q naught is basically equals to 1, 0, 0. The state sequence, you need to find the sequence for next 3 clock cycles. The options are 0, 0, 1, 0, 1, 0, 0, 0. Second is 1, 1, 0, 0, 1, 1. Maybe I can use 3 options only. 0, 1, 1, 1, 1, 1, 1, 0. Yeah. Is the question clear to everyone? Please let me know even if the question is clear.
Hello.
Yes,
Hello.
yes, who's this?
Your voice is not clear.
Sorry,
Your voice is not clear.
is it the case with everyone? My voice is clear, right?
Yes, sir.
Yeah, so check your internet connection, whosoever is saying.
Okay, sir. I will check that.
Yeah, so as we are doing this question, so this is like a counter circuits. So we need to check what is the sequence. Initially, what it is basically saying that the Q2 is basically one. Oh, sorry. The initial sequence that is stored is 100, and if I use the sequence again, what will be the, yeah, so one thing is I have not made, so every circuit is having its own clock. Hmm. So using this circuit, just try to see that. Can I write J2 is equals to Q1 bar, K2 is equals to Q naught? Is it clear to everyone? Because I have made the connections like that. Please let me know if it makes sense to everyone. So J1 is Q2, similarly K1 is Q2 bar. Here J0 is Q1, sorry, K0 is Q1 bar, not Q1, Q0 bar, sorry. So this is not. So now using this, we can easily get the next state. So let's make that table. So it says Q2, Q1, Q0, and we know what are J2, K2, J1, K1, J0, K0. And basically we need to find the next state, that is Q2 plus Q1 plus. So writing plus means basically n plus 1 state. So the initial states it's 1 0 0, and we know the relations between j, k and everything. So j2 is basically q1 bar, so q1 is 0, so j2 will be 1. Is this clear to everyone? How I have written j2? So let me quickly write here also, that will be easier. So this is actually q1 bar, this is q0, this is q2, this is q2 bar, this is q1, this is q0 bar. So now using this relation I can easily find out. Oh sorry, yeah, I can use the blue only. So this is 1, K2 is Q0 which is 0, J1 is Q2 which is 1, Q2 bar is 0, Q1 is 0 and Q0 bar is 1. Is it clear to everyone? Please let me know if it is clear. Yeah, great. So Q2 plus we can easily calculate using the excitation table. If you all remember, when J2 and K2 are 1 0, sorry, not the excitation but the truth table. Let me make that also. Since we need only 3 cycles, so let me make it here only. So it was 0 0 1 1 0 1 0 1, so it's Qn, it's 0 1 and Qn bar. So when both are, so here J2 and K2 are 1 0, so 1 0 means Q2 will be 1, again 1 0, so it will be 1, so it's 0 1. Sorry, where did it go? Oh, I need to write it again, sorry for that. So the initial state is 1 0 0, so this is basically Q2 Q1 Q0, J2 K2 K1 K1 J0 K0, and this is Q0 plus Q2 plus Q1 plus Q0 plus. So again using the expressions that are given, I can write this as 1 0 1 0 0 1, and from this I was getting 1 1 0. So this is basically the next cycle, which is 1 1 0. Now we'll do the same thing again. So when J2 and K2, okay, let me write those things again. Sorry for the glitch. This is Q1 bar, this is Q0, this is Q2, this is Q2 bar, this is Q1, and this is Q0 bar. So I'll write this again: 0 0 1 0, then it is 1 1. So now when it is 0 0, so it's hold the state, so it is 1. When it is 1 0, it's basically whatever the state is, it's 1, and 1 1, it's the toggle, so it's 1. So now 1 1 1 is the next state. Again we can use expressions, so you'll get 0 1 1 0 1 0. So at 0 1 it stores, so it's 1. Sorry, 0 1 it's reset, then 1 0 it's set, and 1 0 it's again set. So 0 1 1. So we have got the state. So from 1 0 0 it went to 1 1 0. From 1 1 0 it went to 1 1 1, and then it went to 0 1 1. Is it clear to everyone? I think the options are gone, but yeah, the correct answer is 1 1 0 1 1 1 and then 0 1 1. Please let me know if this is clear. Great. Let's do maybe one more good question. Yeah, so these are all very basic question. You can check them later in the slides. I'll update this slide. So these are very basic questions. So this is actually a good question. Let's try to do this and then we can wrap up the session. So now it says in the circuit, choose the correct timing diagram for the given waveforms W1, W2, W3, W4. So here what do we have? We have a D flip-flop, right? The inputs of a D flip-flop are X1 and X2. And the outputs are like this. So let me name them. So why can I write Y as Q1 times Q2? I hope it is clear. So this is 1, 1. Let me use some dark pen. Yeah. Is it clear from the diagram that Y is Q1, Q2? Please be interactive and yeah. So this is a negative edge triggered flip flop because the clock is a dot and then line. So the positive edge flip flop is like this, and the negative edge triggered flip flop is like this. So we have to check at all the negative edges, which is this. So maybe I can make a diagram here only. So let's try to make maybe Q1. So if I start with 0, the first change that will happen is here. So Q1 is basically, because it is a D flip flop, so Q1 is X1 only and Q2 is X2, right? Is it clear? Because the Qn plus 1 is D only. So if I check here, the first trigger, the X1 is 0, so it will remain 0 till the next trigger. Here the X1 is 1, so it becomes 1 till the next trigger. Here the X1 is still 1 till the next trigger, and then yeah, it's still 1. Is it clear how I've written the Q1, everyone? Great. So I can write the Q2 also like that. So maybe I'll use the blue ink for that. So now I have to check for X2. So let's say I start with 0. So let me make cross cross so that it looks like we've done. So here you see X2 is 0 at the first trigger, so it will remain 0 till the next trigger. Then X2 is still 0, so it will still remain 0. Maybe I can make a straight line also. Then at this trigger, X2 is still 0. And at this trigger, it becomes 1. Is X2 clear to everyone? The blue line?
Not clear, sir.
Sorry?
Not clear.
X2 is not clear, you are saying?
How the X1 and X2 is having the
No, X2 and
this
X2
word.
are X1 are given in the question. We are trying to find Q1 and Q2. So Q1 is basically equals to, or Q1 plus is equals to D, right? And D here you can see
Yeah.
it's X1. So from that, since this is a negative edge triggered flip flop, so whatever X1 is at the negative edge, I'm just trying to have that in here. So for example, the Q1, let's focus on red one. So since here X is 0, so it will remain 0. The red line, if you see it remains 0. Here at the second edge, the X1 you see becomes 1. So here I made it 1. Now at the third edge, it again became 1, so it's still 1. Yeah. So this is how made q1. Make sense? Please let me know if it is clear.
Now the clock when it is become down zero, but x in that case is one.
Say it again.
In the clock when it is
Huh.
zero, but x is one.
Yeah.
Then how it converts to this state line on
It
a one is
only
coming?
Yeah, it only happens, the transition only happens at all the negative edge triggering. So here you see x is 0, so it should remain 0. Here you see from at the transition the x is 1, so it should remain 1 here. Here you see at the transition the x is 1, so it should always remain 1. It does not care about what is happening in between. It only triggers when there is a negative triggering
Okay.
of the clock. So similarly, if you see for even for x2, that will make it clear, I think. So x2 you see at the negative edge triggering here it is 0. So x2, that is the cross points. So at this particular point it will remain 0 only. Now at this point you see it is still 0, right? At this negative edge triggering. It does not care what is happening in between, but here it is 0, so it will still remain 0 till the negative edge trigger. And at this trigger it is still 0 actually at this point. So it is still 0. At this trigger it becomes 1, so now it has become 1. So this is the q2,
Okay. Okay.
and basically the output is the AND combination of this. So q1 times q2 will be, so 0. So if you can see, what will be the answer? W1, W2, W3, W4.
W1.
How can W1 be the answer? And you know the truth table of AND, right? X, Y, and let's say AND of X, Y. So when 0, 0, 1, 1, 0, 1, 0, 1. So it's 0, 0, 0, 1. When both of the inputs are 1, then only the AND becomes 1. Anyone? Yeah, it should be W3, right? Because here it is 0, 0, 0, then here it becomes 0, and here it is 1 and 0. So it should always remain 0 till here, which is the only case in W3. And at this point, both of them becomes 1. So which is the case here. So W3 is the correct answer, which is option C. Is it clear, everyone? Yes. Uh,
Yeah, yeah.
is there any doubt? Whosoever has raised their hand?
Yeah, I have. In the question that you gave XY and make it using JK flip flop.
Okay.
In that 0 1 0, it is actually not a valid state, right?
So which one?
The third input
This.
0 1 0 Qn should be equal to no, it cannot be equal to 0, right? So it should be an invalid state, right?
Let me try to see what you are trying to. So you are saying this state.
Yeah,
So here what you are saying? What is the doubt?
that will be an invalid state, right? Because Q n cannot be 0
Why Qn
according
cannot
to
be
the
0?
previous table that you have given.
Yeah, how? Why are
0
you?
1,
Yeah, so when it is 0, 1, when x and y are 0, 1, right? It says it is
yeah,
1.
yeah, and Qn should be,
No, no, the qn plus 1 will be 1, right? So qn can be anything. So this, please consider this as the inputs. This is what we have written in order. We are actually calculating qn plus 1. So you have to take all the combinations. So from when it is 0, 1, you can say qn plus 1 will be 1. You are not caring about what is qn actually. You are only caring about Qn when the inputs are either 0 0 or 1 1. Are you able to understand this?
No, can you explain it again?
Okay, so what I'm trying to say, let's say I have made an input table which involves x, y, and qn. I'm not caring about whether qn is 0 or 1, but now I know that when x and y, for example, are 0 0, I know my qn plus 1 is qn complement. So that is why I've used the value of qn to make it the complement. But I know when my x, y are 0 and 1, it should always be 1. It is not an invalid state. Whatever the q is, it should always stick to 1. It does not depends upon qn. The only two states that depends upon qn are 1 1 and 0 0. So in 1 1 you see it is qn complement. But since 1, at the moment when x is becoming, let's say, 1 0, you know that the qn plus 1 will be 0. You don't care about what is qn. You cannot say it is an invalid state, because x and y are the relation between qn plus 1. uh, like this is how we make the truth table
Okay,
in terms of characteristic table.
okay, okay.
Is it clear?
Yes, sir.
Okay, yeah, great. So yeah, I think these are all the good questions that I had for this particular lecture. Maybe you should all watch the recording again, because this is actually a very interesting and very important topic for this particular course. Uh, and yeah, maybe we can continue to do some more questions in the next week, because that also involves some of the sequential circuit problems only. So yeah, till then, I think we can wrap up the session. If you have any doubts, you can mail me anytime again. And yeah, thank you for joining, everyone.